So, hi all. Today we are going to discuss the topics file system organization and implementation and IO subsystems. So, first, what is a file? So, you all know very much about file subsystems and files. So, files are named entity on a magnetic disk or optical disk or system memory or memory stick. So it contains data, characters, text, numeric values, etc. Okay. So OSs differing abstractions of a file. That means different OSs are having different abstractions of a file. So in one OS, it may be interpreted as a file may be named entity that is a structured record named entity as on a disk which has having random access in the system. That means a file is simply itself it is a named entity, that is it has a structured record name that will have a random access in the memory. That means the file is simply a named entity which is a structured record that having the access to the RAM, that is a random access memory. So it is another way it is interpreted in different way in another voice. That is, it may be structured record on a RAM, analogs to a disk, and may also be either called separately called as RAM disk. It is similar to the above description. Okay. So this is another way of interpretation in different ways. That means maybe an unstructured record of bits or bytes. That means in another OS, it may be unstructured also. A file device may be a pipe-like device. It may be a pipe. You have already studied about pipe, right? So next is file organization. That is our topic. So file is organized in a way according to a file system which has set of command functions for operations on the file. That means it is actually organized, it is actually stored in a file system. That file system we are actually having a set of command operations. That means we have to operate or we have to execute some functions or some commands on that file. So we have to set some command functions and operations on the files using the file organization in a system. Next is the standard set of interfaces. So, next, should a file having integers differ from the file having bytes? Or should a file having bytes differ from a file having characters? That is two types of question. That means actually we are having different files. We are having a files of integers and characters, and uh, we are checking whether they are having different bytes. So this is having different approaches. So different approaches are carried to perform uh, these two operations, these two questions. Sorry. So due to the differing approaches to devices and file management interfaces, the development of a set of standard interfaces must. There, here we are using different approaches in different OSs, in different interfaces. So there is a necessity for developing a set of standard interfaces. Then only the systems can be portable. That means only a standard interface is necessary. Then only the systems can be portable. So next is very important. That means we are having two types of file systems: block file system and byte file systems. So what is block file system is, its application generates records to be saved in the memory. That means how it is saved is first structured into a suitable format and then translated into block streams. That means the data is structured into a suitable format and then it is converted into a block stream. So there we have a file pointer, that is a record pointer, otherwise called record pointer. It will points to the block from the start to the end. That means we are having a file system. You have already studied in CO a file system, how a file system looks like or a memory looks like. So there we having a file pointer that will point from the beginning till the end of the file. So next one is, first one is block file system, next one is byte stream file system. So byte stream file system, that its application generates record stream, then these streams are to be saved into the memory. So it generates record stream, then the streams are saved into the memory, then these structured into a suitable format and translated into byte stream. So first it records streams, then streams are saved, then it converts it to a structured format, then it is translated to byte streams. So if we are having a file of n bytes, there is a file pointer that will point to a byte from the start index 0 to n minus 1, which is having n bytes. So POSIX. POSIX means it is a standard set of interfaces. That means there are no lot of interfaces. So POSIX is an standard set of interfaces. So here the file operations are as the operations on a linear sequence of bytes. That means here we are performing all the operations in linear sequences. The what is POSIX? POSIX is portable operating system interface IEEE standard. So it is portable operating system interface IEEE standard. So it is actually used for coding the programs when using the multiple threads. So there are many multiple threaded operating system possible. So when you're using multiple threaded programs, so we have to code that programs in the POSIX environment. Okay. So then X after I is because of the interfaces being similar to one in Unix like. It is according to the definitions of AT&T Unix system V interface. So next is a very important part. That means set of command functions in the POSIX file system. So first one is open. So open means it's actually function. It is used for creating the file. So open, which is used for creating the file. Next one is the write. So write is used simply for writing the file, or otherwise called in the byte stream at the present pointer position. That means writing the writing the data into the byte stream where the pointer will points. Okay, next is the read. Read is reading the file, that means from the byte stream present pointer position. Next one is lseek, or otherwise we are calling as list seek. So which it is important. List seek is used to set the file pointer in the byte stream. So I have already said that there is a file pointer. So file pointer, we have to set that file pointer into the byte stream. So for that, we are using the function list seek. Okay, next one, F control, actually controlling the functions, controlling the operations on the stream. We are using fcntl. Next is close, close which is used for closing the file. So Unix and Linux file system, that is the difference between them. Unix has a structured file system with an unstructured hardware interface, and Linux supports different standard file system for the system. So here are the main differences. That means file devices are block devices in Unix, but in Linux we use block devices as a char devices, because there is an additional interface between this block and char. So this interface is actually termed as kernel interface. So next one is RAM disk. Now these are all just describing the hierarchical structure. That means for accessing the path of a file, we have to describe its directory, then the subdirectory, folder, subfolder. That means it follows a hierarchical tree like filing organization. Next is file descriptor. It is actually not necessary for you. So file descriptor is an integer which returns an opening a file and which points to a data structure. So these are all important to you. That means the data structures, file describing data structures. So first one is identity. Identity means name by which a file is identified in the application. That means actually the name, we can only identify a file by its name. Okay, so that is what is called identity. Next is the creator or owner. That is, creator or owner means process or program by which it was created. Who was creating the program is the owner of that program, right? So next is state. So state can be a closed, achieved. Achieved means saved state. Okay, closed state, saved state, open executing file or open file for additions. Next is logs and protection fields. So logs and protection fields, there are two types of operations that is run. That is for open with read and write permissions. Next is file info. File info current length when created, when last modified, when last accessed. Next is sharing permission. So it can be shared for execution, reading or writing. Next is the count. Count is the number of directories referring to it. Next is storing media details. It means that blocks transferable per access. Okay. Next topic is IO subsystems. So IO subsystems means, so IO subsystems. So IO subsystem means there are IO ports are in our systems. Subsystems are used for OS device management systems or UART. UART means Universal Asynchronous Receiver or Transmitter. UART, which is already you have already studied in your first module, what is UART? So UART access subsystems and the parallel port access subsystems. So they are used by drivers. That means our system actually contains device drivers. So IO ports are actually used by device drivers to communicate with the different devices that is using our IO ports. So IO instructions depend on the hardware platform. So that means it is actually completely depending on the hardware platform where the IO instructions are used. IO subsystem different in different OS. That means we different OSs are using different IO subsystems. So if they are using different subsystems, then they are performing different IO instructions also. So IO subsystem in a typical IO system at in an OS, that means application, IO basic functions. So application is an application having an IO system. There may also be a sublayer between the application and IO basic functions. That is, application is simply an application. There is a layer, there is a sublayer between application and IO basic functions. So IO basic functions means these are device dependent OS functions. That is, these are device independent. These are device independent OS functions. For example, if a file system functions for read and write, buffered IO or file, read and write operations. That means file system functions for read and write are all examples of IO basic functions, right? Read, write, etc. There may also be sublayer between the basic. That means there is another sublayer between the IO basic functions and IO device driver functions. So what is IO device driver functions means these are device dependent OS functions. So IO basic functions, it is actually independent, device independent, but IO device driver functions are device dependent OS functions. So a driver may interface with a set of library functions. For example, it's for serial communication. Next is device hardware or port or IO interface card. So it is actually serial device or networks. So what are the IO operations? So I have already said that OS are having different IO operations. So we are using different types of IO instructions. So we are having two types of OS differing IO operations. So first one is traditional OS synchronous IO. That means our traditional OS, that is a Windows, Linux, and so on. So here at a certain fixed data transfer rate. That means here the data are transferred at a fixed rate. Next is the RTOS, that is real-time operating system, which is using asynchronous IO operations. That means at the variable data transfer. RTOS is completely time dependent, right? So it depends. It actually uses variable data transfer rates. That means according to the time and the speed, the data transfer rate may vary. Next is the synchronous IO operations. So synchronous IO operations, they are transferring the data at a fixed speed. That means therefore a task blocks till completion of the IO. For example, a write a function write for 1 KB data transfer to a buffer. Synchronous IO operations, when it is transferred to the buffer, until the 1 KB is transferred, the other data which is actually in the ready queue, it is being blocked until the 1 KB is transferred. Similarly, like read operation also, once initiated blocks the task till 1 KB is read. Until 1 KB is read, the other one is blocked. Next is asynchronous IO operations. That is already I have said that variable data transfer rates permits that a process of, that means high priority processes are high priority process run at the high priority process will run first, and then the low priority processes. Next is POS6 asynchronous functions for IOs. So these are the POSIX asynchronous functions. Okay, read, write, list, error, suspend, and return. Okay, this is so we have already completed up to IO subsystems. That means file systems, file organization, IO subsystem. Next, we have to cover the task scheduling. Okay, that we will discuss in the next class. Okay, thank you.